We're now moving on to exercise 4 in the airflow demonstration unit lab session, and this is looking at shock loss across our expansion and contraction plexiglass duct here. I hope you don't mind. It's actually quite a struggle to remove the steel duct and put this in, simply to take one measurement, flip it around to take another measurement, and then put the steel duct back in. So please bear with me and thank you, I appreciate that. So again, this one is kind of interesting. We have air flowing into the original size duct. We go through a gradual contraction to a constant size smaller duct, and then we discharge through what would be considered a sudden expansion from the smaller duct into the original size duct. Once again, we're looking at the shock loss factor here, which is defined as X is delta P, delta static pressure in this case, across the assembled duct here, divided by the velocity pressure. So in taking the readings, in this orientation, from the upstream side to the downstream side of the expansion contraction segment, the overall delta P is 2.903 inches of water column, and the velocity pressure is 0.329 inches. So here is the data sheet for this exercise, which we've talked about. So this one goes very quickly to take the data. This takes a lot of monkeying around to get it in place. Now we'll do a simulated swap of this 180 degrees, like so. Now air coming in, the original duct faces a sudden contraction here, flows through the smaller size duct, and then we have a gradual expansion back to the original size. So we've just reversed the order of the obstructions there. And in this case, taking the overall delta P from the upstream to the downstream side, delta P is 2.455 inches of water column, water gauge, and the velocity pressure is 0.395 inches. Okay, so there's those numbers. Now, as we did with the flow regulators, studying shock loss across the flow regulators, this is the definition of a shock loss factor, and once again, you can just calculate this directly. So you've written down the delta P and the velocity pressure, so just divide one by the other and you'll get the experimentally observed shock loss factor. Then in a separate video, I will show you how to calculate the shock loss factor without having to do an experiment. There are equations for that, but again, as was the case for the shock loss across the flow regulators, it's very involved. I will need to do a separate video for that. But this is our expansion, contraction, shock loss exercise, and we're almost done.